Welcome to clickmyproject.com. Let we discuss about the process, a hybrid image compression scheme using DCT and fractal image compression. Let me see the abstract of the process. The compression of color images has many applications in most of the mobile technologies. Reducing the time taken for file transfer is more important in all of the mobile applications. A compression process should reduce the number of bytes in the images without reducing the quality of the images. A compression method is proposed that compress and decompress the input color images efficiently. The color images were pre-processed using median filter. This will reduce the noises, that is the unwanted pixels in the input images. For compression, we are combining several schemes to produce better compression results and compress the images with high compression ratio. The pre-processed color image is compressed using DCT. The DCT is most commonly employed in all of the compression schemes, mainly in JPEG compressions. A discrete cosine transformation expresses a finite sequence of data points in different terms of a sum of cosine functions oscillating at different frequencies. Zigzag process is applied to the obtained DCT coefficients. The zigzag processes will exploit the number of zeros in the DCT coefficients. The zigzag applied DCT coefficients are then decomposed using quadri decomposition. Encoding is applied to the quadri decomposed images using fractal method and run length encoding method. The compressed image is then decompressed by reversing the whole process to the original color image. Finally, the performances of the process is measured by calculating compression ratio PSNR value. The compression and the decompression processes employed here is more efficient since it compresses the input images with high compression ratio and decompresses the images with less distortions, which produces high PSNR value. Let me see the flow of the process. First, the color images is obtained and discrete cosine transformation is applied to the input color images. This cosine transformation decomposes the images and produces the DCT coefficients. For the obtained DCT coefficients, zigzag scheme is employed. After zigzag, the coefficients were splitted, producing more confused parameters for the extraction of the images. After that, quadri decomposition is applied to the zigzag coefficients obtained. The identified zigzag coefficients were decomposed using quadri decomposition. The quadri decomposition processes minimizes till the number of pixels in the zigzag coefficients obtained. After that, fractal encoding is obtained to make it a single values for the calculation of the processes. And finally, for the fractal encoding applied, run length encoding is applied. So as we can see, finally the total number of bits comparing to the input color image is reduced comparing to the resulting run length encoding processes. After that, these processes is reversed in an exact manner in order to obtain the decompressed images, which is visually similar to the input color images. So for that, first the compressed images is run length decoded. So after the run length decoding processes, fractal decoding is applied. Then inverse zigzag is applied. Before that, the quadri decomposition were reversed in order to obtain the exact sequences. After that, then inverse zigzag is obtained. Finally, inverse DCT is obtained in order to retrieve the original decompressed image. Finally, the overall performances of the processes is measured in terms of compression ratio, PSNR and the MSE of the process. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the user interface for the execution of the process. So select any one of the query image which is present in the dataset. After this, the RGB channel separation is employed. After that, the basic pre-processing step is employed. So compared to the input image, in the pre-processed image, the overall intensities of the images were smoothened. After that, the compression process is employed, which is based on first DCT. So the DCT coefficients were applied here. After that, the zigzag coefficients were applied to the DCT transformations, and finally quadratic decomposition images is obtained. Finally, fractal and the run length encoding processes were employed. After that, the decompression process is employed. So after the decompression process, the same processes were repeated. The fractal and the run length were decoded for initially. So after decoding, inverse zigzag scanning were applied, and finally inverse DCT is applied. So as we can see, the input images is compressed and decompressed as a result. So this compression, the decompression process may be helpful in the secure transmission of the images also. Finally, the performances of the process is measured in terms of the performance analysis, like the compression ratio, PSNR, MSE, SSIM, normalized cross resolution, absolute definition, compression time, and decompression time. Overall, these performances were measured from the input images. So thus we have compressed and decompressed the input images based on different compression methodologies, and we have decompressed the same using different decompression using the same methodologies, and finally we have measured the overall performances of the processes. Thank you.